Hello everyone, this is Cole Dobbinspec with the Sprint 3 overview of the Radar project. So this is the GitHub milestone for Sprint 3. So for Sprint 3, what I was working on was adding command parsing, so that way useful information could be extracted from the commands that users are running, and then use that information to then add automation. So the goal of this is that for like offensive cybersecurity during penetration tests, users would be able to run commands and gather information automatically and then automate some of the workload that they would always be doing. So that way it happens consistently and as quickly as possible. So that took a good amount of time, and basically that was what this sprint was. This is preparing for the upcoming sprint, Sprint 4, where I work on kind of ironing out any issues as well as adding distributed commands, so that way not only can you work faster as an individual, but you can work faster as a team as well. So for the user-facing demo, let's hop over to the command line, and it starts up just like it was before. I restarted my virtual machine, so it has a bit of oddities with the SSL certificate right now, but that it works perfectly fine. It asks which mission I want to join or create. I cleaned up my database, so it's blank right now, so I'm just going to call it Sprint 3 and hit enter, say yes, I want to create it, and then I can work with Radar just like I did before. So I'm actually going to run a Nmap scan on my server to see what's running on it. And you'll see once that completes, it prints out the output just like before. It's running port 21, which is the FTP or file transfer protocol. It's running 22, which is SSH for remote console access command line, and then a few other services as well. And you can see down below it, this is the Radar output for running playbooks, which is the automation component of it. And what happened was that it saw that port 21 was open, which is FTP. And since FTP is open, then it checked to see if it allows anonymous login, which is just where a user can log in without like authenticating and view all the contents. So obviously that's a really bad thing, security risk. So it automatically ran that playbook based on the output here and then found that vulnerability. If I run an Nmap scan of just my current computer, you can see port 21 is not in the list for FTP. And when it ran the playbook, it didn't find anything because FTP wasn't open. So when I go to list the collections in the current mission database, you can see there's 3 now. And if I read the targets database, you can see here's like parsed output from that scan that I ran. So this is for localhost. It's fully parsed out. And then for my server, you can see it has the vulnerabilities section where it lists out vulnerabilities that it found, and then all of the ports and services that were running on it. So this way you can collect all the results from your assessments in a standardized format. All of this JSON is conforming to the specifications that I outline in my README file, so that way it'll always be this format. If I read the command metadata, you can see it has a lot of information. So when this data was inserted into the database, what command was run, and then even more information about the Nmap scan. So this is just all of the output from the module that was used to parse the command. If I run a different command, so just like dir to list the contents of my current directory, if I do the same thing with command metadata, You can see it doesn't have that parsed information because it wasn't an nmap command, so it didn't get parsed as an nmap command. So every command will be parsed differently depending on the rules that are defined. So let's hop over to the code and let's figure out how everything works. So this is the manager for the command parsing. So I'm using a rule language called Yara. Yara is a malware signature engine, so it's used to find malware, but it can also be abused to do what I'm doing here. So what it's doing is it has a rule file that says how to parse certain things. And what it does is it compiles all those rules when it creates the command parser manager object. And then whenever there's a call to parse, it takes in a command and then runs it up against each one of those rules to see if there's a match. And then if there's a match, it dynamically loads the Python module based on the rule. And if the parser loads correctly, then it calls it to parse the output, and then it joins all the results together and then returns it. So in the client, you can see what happens is it runs the system command, and then from that system command, it tries to parse out any metadata or target data from the parser manager, and then once it's parsed out all that information, it then runs any automations that may be available depending on what is in the target information. So this is what a Yara rule looks like. So this is the nmap rule I made, and what it's doing is if it sees the string that there's an nmap scan report for, it'll run this, or this rule will be true. And when this rule is true, from the metadata of the rule, there's this module field, which then gives it the name to the module. So this would be parser_nmap, which corresponds to this module. And then this module has a run function that takes in the system command object, and then it just parses the output from the command line by line here. And then once everything has been parsed out, it returns the results and then any target information that it also extracts. If we hop back over to managers, the playbook manager is very similar. It just handles everything a bit differently. So if there's a list of targets, like let's say you don't just do a scan of a single computer, but you scan multiple, there will be a list of targets, and each target is then run against the playbook rules to see if there's a match. And if there's a match, it does the same thing, where it dynamically loads the module and then executes the module. So for the scanning anonymous FTP, this is what the rule looks like. It checks to make sure that the port is 22 and that the service is running some type of FTP. And if those are true, the scan anon FTP module specified, so then this is executed. And what it just tries to do is it just tries to open up an FTP connection with an anonymous login. And if that's successful, it then adds information about the vulnerability to the target information. So my approach is pretty modular. Definitely some of the challenges was just getting all the specifications correct, because everything needs to be formatted as the managers expect, because if it's missing the correct argument type, or the name is misspelled or anything like that, there will be an error that's thrown. So there's little bits and pieces that are spread throughout the code, but they all need to be consistent in order to get this to work. So if you wanted to add a parser or a playbook later on, you just need to create a new file and then create a rule in the YAR rules, whichever one it is. So if it's a playbook, create in the playbook rules. If it is a parser, put in the parser rules. So it's really easy to add these modules in the future as well. So if you have any questions, the best place to look would be the GitHub. There might be an issue open that you could comment on. And you can track the progress of the Radar project through the issues page.